This is the screencast for section 6.1, example 2. We're going to look at magnitudes of vectors. Well, a magnitude of a vector is essentially its length. A magnitude of a horizontal or vertical vector would be easy because it would just be the difference of the x-coordinates or y-coordinates respectively. But assuming a vector is on an angle, we can use the Pythagorean theorem to determine its length. Now, we have a situation in example 2 where we're looking at a vector that is not in standard representation. So we can either use the head minus tail first, and head minus tail rule first, and figure out what the vector would be in standard representation, and then find its magnitude, or we could do the subtraction within the magnitude formula or distance formula itself. It's up to you. I'm going to do the head minus tail rule first and find out what this vector is in standard representation. And then as you can see from the diagram before, the vector PQ is also equivalent to the vector -2, -2. So now I can just use the -2 as the x-coordinate and -2 the y-coordinate of the standard vector as the change in x and change in y to find magnitude. So I found that the magnitude of vector PQ is 2 square root 2. The Now Try problem number 5 asks us also to find the component form and magnitude of the vector, so I am definitely going to use the head minus tail rule first and then use the distance formula, or magnitude formula in this case, to find its magnitude. So first, by the head minus tail rule, vector PQ is also equivalent to the vector 5, 2, meaning the vector that starts at the origin and points to the point 5, 2. So now I can use the magnitude formula to find its magnitude, and I get that vector PQ has a magnitude of the square root of 29. And if you notice, absolute value is being used to represent the magnitude, and if you remember from, I don't know, way back in Algebra 1, absolute value means its distance from 0, and we're talking about its distance from the origin.